Hello. We're going to look at section 2.3 today, which is about deductive reasoning. Page 8 is going to be the page in your notes that you need to get to. So if you want to find page 8, we can get started. Okay, first, defining deductive reasoning. So deductive reasoning, you're going to be using facts, definitions, accepted properties, and laws of logic to form arguments. Now remember, you can pause this video at any time so that you can get caught up with your writing and then resume it to listen to what I'm going through. One thing I want you to pay special attention to is how different this is than inductive. Using facts, definitions, etc. So we are not looking at patterns. Remember that inductive, we looked at patterns, and then we made a conjecture based on what we saw. Deductive, we need to have some sort of factual information. We need a proven scientific fact. We need a definition in math. We need a theorem, that type of thing, in order to form an argument. So we're going to start by identifying, are these scenarios inductive or deductive? Okay, so scenario number 1. Plants can grow to be healthy when given sunlight and water. Mark's plant receives sunlight and water each day. So Mark's plant will grow to be healthy. So is this inductive or deductive? Well, when I look at what I'm given, I am given the fact that Mark is making sure that his plant receives sunlight and water. So based on what he's doing, his experience, his plant should be growing to be healthy. This is an inductive reasoning because it is just based on his pattern of behavior. It's not based on any scientific evidence. It doesn't come out and say, because he is following the laws of growing plants, that his plant should grow. Okay, so he is impacting the growth of it by his behavior, and he is looking at a pattern here. Okay, part B. The rain stopped, the sun came out, next a rainbow should appear. So do you think this is inductive or deductive? I observed the rain stopping and then the sun came out. So in my past, I usually see a rainbow. Okay, this is also inductive. This is because I have normally seen a rainbow appear. We all look for rainbows. Sometimes we don't see them though. So this is inductive versus deductive because it's based on what I have observed in the past and what I expect to happen in the future. Next one. Jose puts $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into savings during this period. Well, let's see. Do I agree with that? If he puts $25 into savings each week, he does it for 10 weeks. So when I calculate 25 times 10, I get $250, which is what this says. So I have used a process in math, multiplication, which is a previously proven way to calculate numbers. So this is deductive. So generally, if you can calculate an answer through some mathematical process, you're going to be using a deductive reasoning versus just an inductive type reasoning. Okay, I want you actually to pause the video, and I want you to try D, E, F, and G, and see what you get. Okay, so pause the video first, and then come back after you've given those an initial shot, and let's see how you did. Okay. Part D, quadrilateral ABC is a rectangle. ABCD is a rectangle. All rectangles are parallelograms. So quadrilateral ABCD is a parallelogram. So because I know that in a property of parallelogram rectangles is they are also parallelograms. So I am using this logic and this mathematical fact to deduce that this is a parallelogram. So this is deductive. This is deductive. Part E, if you pass algebra 1 with a C minus, then you move on to geometry. Joe failed algebra 1, so he is not in geometry. So if this is the rule, and by the way, this is the rule at Lee Summit, if you pass algebra 1 with a C minus, then you move on to geometry. So he failed algebra 1, so I can use logic because this rule exists that he must have a C minus. So this is deductive. if this was inductive, it might say, I have a couple friends in Algebra 1 who got a D, and they're not in geometry, so you must have to retake Algebra 1 in order to, because they didn't get a certain grade. So if you saw it happen with a couple friends, that's inductive. If we have a rule in place, that's deductive. Okay, part F. Ken has eaten a peanut butter sandwich every day this week for lunch. Tomorrow, Ken is going to eat a peanut butter sandwich for lunch. This is what's happening. I'm observing this. Therefore, I think he'll do it in the future. This is a pattern, inductive. Okay, lastly, all of Sarah's friends have cell phones. John has a cell phone, so he is Sarah's friend. This is inductive. Part of this is looking at a pattern that he has a cell phone, so therefore he must be her friend. Okay, this is again just kind of making an observation on what's happening here. Okay, so step 1, deductive is factual, and inductive is more pattern-based. Okay, we have 2 laws of logic we're going to look at. The first is called the law of detachment. The second is law of syllogism. So law of detachment is a very basic logic law. So it says, if the hypothesis of a true conditional statement is true, then the conclusion is true. So if the hypothesis is true, the conclusion is also true. Okay, so let's actually move on to that first, those examples, and then we'll come back to syllogism. So like I said, this is very basic. So when we go through it, it will feel a little bit like common sense, but it's where we need to start on logic. So use the law of detachment to make a valid conclusion in the true situation. So it says, if 2 segments have the same length, then they are congruent. Okay, that is the statement we're taking as truth. So next sentence says, you know that BC equals XY. So if I break this down a little bit, my hypothesis is right here. If 2 segments have the same length, the conclusion says they're going to be congruent. So the law of detachment says that if the hypothesis is true, then the conclusion is true. Okay, so I have now encountered this situation. You know that BC equals XY. So I have encountered 2 segments being the same length. So this matches the hypothesis. So the law of detachment says I can assume the conclusion will occur. So I can assume that they are congruent. And so that is the answer by using the law of detachment. Or I might want to write it with math symbols that BC is congruent to XY. And that's all the law of detachment says. So if I encounter the hypothesis in a scenario, I can detach the conclusion from it and assume that will happen. Okay, so let's look at the next one. Mary goes to the movies every Friday and Saturday night. Today is Friday. So I want to actually rewrite this sentence in the form of an if-then. Mary goes to the movies every Friday and Saturday night. So my if-then statement, actually being Friday or Saturday night is my hypothesis here. So if it is Friday or Saturday night, or Saturday, I'm going to do a little abbreviation here. If it is Friday or Saturday night, then Mary goes to the movies. Mary goes to the movies. Okay, so my hypothesis. Friday, if it's Friday or Saturday night, then she's going to the movies. Okay. So here's the scenario to consider. Today is Friday. Well, based on my if-then statement, if it's Friday or Saturday, she goes to the movies. So I am concluding Mary will go to the movies. Mary will go to the movies. So to sort of break down an example that would not qualify for law of detachment, let's say I change this a little bit. If I were to change the second sentence here to say, Mary goes to the movies, you would not be able to conclude it's Friday or Saturday night by the law of detachment, okay? Because it doesn't say she only goes on Friday or Saturday night. She could go a different night as well. She always goes on Friday or Saturday night. So if I'm presented with the conclusion of a statement, I can't go backwards in a sentence and assume the hypothesis will happen as well. Law of detachment goes from, I have to be given the hypothesis in order to logically conclude that the conclusion will occur. Okay, so that's our first law, law of detachment. Law of syllogism. I'm going to back up here to the screen. So, law of syllogism seems complicated, but we logically do this all the time. So I want you to see here these three sentences right here. Law of syllogism allows us to write a third conditional based on the first two. So if I have a hypothesis called P, then I reach a conclusion called Q. So if I have a second if-then, if the hypothesis Q occurs, notice it's the same as the conclusion. If hypothesis Q happens and that leads to R, well then I can say that P will lead straight to R. Okay, so it's kind of like saying if today is Monday, then we have a normal schedule. If we have a normal schedule, then I go to all my classes. I can conclude if today's Monday, then I go to all my classes. In a way, you're able to sort of cancel out the ending and beginning that match, and we are able to write a new if-then that results. Because if A always leads to B and B always leads to C, well then A is going to always lead to C. Okay, so let's take a look at a couple examples. I like to write this out in a pattern so I can cancel some things out. So it says, this directions say, if possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So I'm always writing a new if-then statement. If possible. If it's not possible, I'll just say not possible. So number 4 says, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So I like to break down the two if-thens, and I'm going to take out all the keywords. So if Rick takes chemistry, Jesse is his partner. So I'm going to abbreviate a little bit. Rick takes chemistry. I'm just going to abbreviate chemistry. That leads to Jesse is partner. Okay, so I just sort of broke it down into hypothesis conclusion. Okay, next one says, if Jesse is Rick's lab partner, Rick will get an A. So, Jesse is partner will lead to getting an A. So in the law of syllogism, if one conclusion matches one hypothesis, then we can in essence cancel them out. So Jesse is his partner is a conclusion, matches Jesse is his partner as the hypothesis. I'm going to circle my new if-then. So if Rick taking chemistry always leads to Jesse being the partner, and if Jesse being the partner always leads to getting an A, well then Rick taking chemistry will always get an A. So I need to rewrite that sentence back in its original format. So I'm going to go back to the original sentence and write down all the details. So my new if-then would say, if Rick takes chemistry, Rick takes chemistry this year, then Rick will get an A in chemistry. Or we could probably cut out the second chemistry because it's in there twice. So if Rick takes chemistry this year, then Rick will get an A. my final statement. So when I do law of syllogism, I should be able to write a third if-then if I can apply this law. So I like to separate out what I've got here. I like to write this sort of process, and if I can find something that cancels from ending to beginning, then I can apply my law of syllogism. Okay, let's take a look at one more together, and I'm going to have you try the last one. Or if you want to try this on your own, then you can pause the video. Okay, so if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared greater than 25. So, hypothesis leads to conclusion. Okay. Second sentence, new hypothesis leads to new conclusion. So do I have any matching parts? Okay, I do have matching parts. It's just a little bit backwards. So I have one ending, one conclusion matching one hypothesis. So here's my new if-then statement right here. And I always want to go hypothesis to conclusion. So if x is greater than 5, then x squared greater than 20. Okay, so that would be my new if-then. Okay, go ahead and try the last one, pause the video, and then come back. We will double check it. Okay, first hypothesis is if polygon is regular, then I'm going to say angles, I'm going to abbreviate here, are congruent. Okay, second one, polygon is regular, leads to sides congruence. Okay, look for an ending and beginning. And I don't have one. See how these two beginnings are the same? So this is an example that I cannot use the law of syllogism. Okay, so I'm just going to say here, cannot apply law of syllogism. Okay, so if you would, let me get the homework assignment up here. Go ahead and do your summary, please. I would like you to take the time to do your summary. And then if you want to jot down this homework assignment, and you can take the rest of the hour to begin it.